In the early 1960s, the world entered a new phase of the Cold War, the emergence of American Minuteman I. Minuteman I missiles required the creation of a new protection system. The Soviet leadership realized the need to develop a reliable early warning system for a missile attack. In the 1970s, the development of the Oko system began. The first tests were carried out with experimental satellites, which were launched into low orbit. One of the test launches brought an unexpected result. A satellite equipped with an infrared complex saw the launch of a rocket, which was actually the work of a jet aircraft. This case confirmed the effectiveness of the chosen concept. The space echelon of the system consisted of satellites placed in highly elliptical orbits. Each satellite was a real technological miracle of its time. Infrared sensors capable of capturing thermal radiation from launching missiles were installed on board. Special telescopes with mirrors up to 1 meter in diameter allowed to observe the Earth's surface. The peculiarity of the system was that one satellite could control a certain territory for 6 hours. At least 4 spacecraft were required to provide round-the-clock surveillance. The satellites conducted observation at a special angle, which allowed to minimize the impact of interference and atmospheric phenomena. The ground infrastructure of the system included many components. Command posts were located in strategically important points of the country. Radar stations monitored the airspace. Data processing centers analyzed incoming information, and special communication systems provided operational data transmission. There were 2 main control centers in the system, the western one in Serpukhov 15 and the eastern one in Pivan 1. They worked in duplication mode, which increased the reliability of the entire system. Automated complexes allowed to process huge flows of information in real-time radar systems played an important role in the work of the SPRN. RO-1 in Olenogorsk, RO-7 in Gabala, RO-30 in Pechora, OS-1 in Myshilevka, and OS-2 in Balkhash. Each station had its own unique characteristics and area of responsibility. The technical innovations of the system amazed the imagination. Vertical observation of the launch of rockets, infrared telescopes with meter-sized mirrors, special solar protective screens, automatic data transmission systems. All this made Oko one of the most advanced systems of its time. During operation, the system faced many technical challenges. The problem of space debris required constant attention. Satellite management was a complex process that required highly qualified personnel. Security systems were supposed to protect against unauthorized access, and protection against interference was supposed to ensure reliability of operation. On September 26, 1983, the system issued a false alarm. That night, Lieutenant Colonel Stanislav Petrov was on duty. Despite the signals of the launch of several missiles, he showed endurance and did not believe the readings of the system. Later, it turned out that the cause of the failure was the illumination of the satellite sensors with sunlight reflected from high-altitude clouds. The system was constantly being improved. The second generation of satellites with improved characteristics has appeared. Digital data processing technologies have been introduced. The number of spacecraft has increased. Each satellite could detect missile launches, track flight trajectories, transmit data to the ground, and work autonomously for 6 hours. The capabilities of the system were impressive. It could detect launches a few minutes after launch, determine the direction of missile flight, calculate the points of fall, and transmit accurate data to command posts. The system was able to track both launches from landmines and launches from submarines. An important part of the system was protection against various types of interference. The satellites had special algorithms for filtering false signals, blinding protection systems, and self-diagnosis mechanisms. Ground stations constantly monitored the condition of spacecraft and their performance. Regular exercises helped to maintain a high level of system readiness. The staff worked out the algorithms of actions in various situations, improved the skills of working with equipment, and learned to make quick and correct decisions in conditions of time shortage. The Oko system was the culmination of many years of efforts by Soviet scientists and engineers in the field of creating space early warning systems. Its development continued until the collapse of the USSR, and each stage of modernization brought new technological solutions. The last significant update of the system was the introduction of improved data processing algorithms, which significantly reduced the likelihood of false positives. Engineers have developed unique methods of signal filtering that take into account even the smallest atmospheric changes. Particular attention was paid to the integration of the system with other elements of national defense. Oko has become part of an integrated security system that includes ground radars, underwater sensors, and mobile command posts. An important achievement was the creation of an automated threat forecasting system. Using the accumulated data and modern computing power at that time, the complex could not only track existing threats, but also predict potential directions of attacks. The system has received improved mechanisms of protection against external influences. Special encryption protocols resistant to hacking attempts have been developed, and systems for detecting unauthorized access attempts have been introduced. During operation, engineers were constantly improving the methods of servicing the space group. Unique technologies for remote control of satellites have been created, allowing you to adjust their orbits and configure equipment without sending repair missions. Particular attention was paid to the training of personnel. Comprehensive training programs have been developed, including both theoretical training and practical classes on simulators. Specialists underwent regular training to practice actions in various abnormal situations. The Oko system has left a significant legacy in the field of space technologies. Many technical solutions developed for this system have been used in modern early warning systems. After the collapse of the USSR, the system continued to function, albeit in a modified form. Part of the infrastructure remained on the territory of Russia. The other part was integrated into the national security systems of the new independent states. The technologies developed for Oko became the basis for the creation of new generations of early warning systems. The experience of operating this system has allowed scientists and engineers to create more advanced complexes that take into account modern threats and challenges. The Oko system became a symbol of the technological breakthrough of the Soviet era. She proved that even in conditions of tough confrontation, it is possible to create unique systems that can ensure the security of an entire country. Her heritage continues to live in modern technologies, and the experience of development and operation remains relevant today.